Hello everyone. So this is the second video on the problems on the linked list. So in this video we will be talking about the problems related to the cyclic linked list. So one of the problem is find the linked list is null terminated or it's have a cycle. So what is a cyclic linked list? A cyclic linked list and element contains the address of its one of the previous elements. So as in this case its last node contains the address of one of the previous elements here. So one solution is brute force solution. So what we will be doing, we will be like traversing the linked list, and if we will be finding the same element again of the linked list, then it's a cycle. Like if we will start here and we will keep traversing here, here, then here, and again our pointer will come here. So if we will find the current pointer and the previous pointer at the same position, then this is a cycle. But this solution will only work if this list is complete cyclic list, like there is no all the nodes of the list are within the loop. So if this linked list will be of that kind, that solution will not work here, because in that case it will go in the infinite loop. It will keep iterating this loop again and again. So this kind of solution can only work with these kind of linked lists. Then we will be discussing about the second solution. So in the second solution we will be using hash table. So how this solution will work: while traversing the linked list, we will storing each node of the linked list in hash table, and if it will be a circular linked list, then one of the element will be inserted again in the linked list, and that we will be checking there in the code. So if this same node is going to be added in the hash table again, then we will find out this is the cyclic linked list. So what will be the complexity of it? On, as we are traversing the linked list only once, and space complexity will be on, as we are creating hash table of all the data elements of the linked list. So this is the code for the algo. Like we are traversing the linked list, and we are checking here, like if that node is already present in the hash table, that is we have found the cycle in the linked list, and we will return true. Else we will be adding the node in the hash table. So if we don't find the same element in the hash table again, that is this is not the uh, cyclic linked list, so we will be returning false. Now this is the third solution. We call it Floyed cycle technique. So in this technique we use the two pointers. One is slow pointer and one is fast pointer. So initially both slow pointer and fast pointer will be pointing to the head, and then we will be moving slow pointer with one step and fast pointer with two steps. So as we can see in the current example, initially both the pointers are pointing to head, then our slow pointer will be moving one step and fast pointer will be moving two steps here. Again our slow pointer will be moving one step and fast pointer will be moving two steps here. Again slow pointer will be moving one step, fast pointer will be moving two steps, one, two. Again slow pointer will be moving one step, fast pointer will be moving one, two steps. Again slow pointer is moving one step, fast pointer is moving one, two space. Then again slow pointer is moving one step, fast pointer is moving 1 and 2 steps. Again slow pointer is moving 1 step and fast pointer is moving 1 and 2 steps. So here fast pointer and slow pointer are meeting. So we found this is the cyclic linked list. So if the pointers doesn't meet, then at one of the nodes we will be finding the null at the end and we will be terminating. So what is the complexity of this algo? On, as we are traversing only once the linked list, and O1 is space complexity because we are not creating any extra elements while traversing. So this is the algo. Initially both our pointers are pointing to head, and then we are moving our pointers, fast pointer to 2 steps, slow pointer to 1 steps, and here we are checking if fast pointer is not equals to null and fast pointer next is not equals to null, and if fast pointer is equals to slow pointer, then we found the cycle and we will return true, else we will return false. Now there is another problem related to the cyclic linked list. If there is a cycle, find the first node of a cycle. So after finding out the linked list is having cycle, then there is one more problem arises. This is finding the first node of the cycle. So this is a bit extension of the Floyed cycle technique that we used earlier to detect the cycle. We will be using the same mechanism. So in our earlier example we saw our pointer met at this node. So from now onwards, as we detected the cycle, we will be moving one of our pointer to start, and after that we will be moving both our pointers by one step. So our pointer will be moving here, another pointer will be moving here, then this pointer will be moving here, this pointer will be moving here, then this pointer will be moving here, and this pointer will be moving here, and the point where both the pointers are met, this will be the starting point of the cycle. So what are the complexities? Time complexity will be O1 and space complexity will be O1. So this is the algo. So here instead of returning the value, we are just keeping the variable is loop detected, and here this is the extension of the earlier algo. If loop is detected, so we initialize one of our pointer to start, that is head, and we are checking if slow pointer doesn't meet to fast pointer, then we will be moving both the pointers by one step. The point when slow pointer will be meeting with the fast pointer, so that point will be the starting, and we will be returning the that address of that node, else we will return the null. So there is one more problem related to the cyclic linked list, that is finding the length of the cycle. So this is also the extension of the Floyed cycle technique that we used earlier. So in our earlier example, our pointers were meeting here. So in this extension, we will be keeping one of our pointer to the existing node, and we will be keep moving our another pointer by one step, and at the same time we will be incrementing one of our counter that will be keeping the count of the nodes. So say we are moving this pointer, so our counter will increment by 1. So 1, 2, 3, 4, 5, 6 and 7. So here both the pointers are meeting again, and we found our counter 7. So this is the count of the all the nodes which are falling in the cycle of the linked list. So time complexity is On, as we are moving only once throughout the list, and O1 is the space complexity, as we are not using any extra space. So this is the algo. So this code is same as it was earlier. Only change is in this code. So we are just keeping a count of the nodes, and we are keeping fast slow pointer as it is, and we are moving our fast pointer by one step. So by the time slow pointer and fast pointer will be meeting, so our count will be containing the number of nodes which are falling in the linked list. Thank you for watching.